Hey everyone, we're here for our next session with Konstantin, the CEO of BlockDaemon. We'll be doing a talk on the bridge landscape, and I'll let him take it from here.
Hey everybody, good morning. Greetings from the Bay Area. I'm sitting near San Francisco in my home office, and I'm excited to talk about bridges. Bridges are obviously a core piece of DeFi ultimately, and I'll talk a little bit about, let me actually walk you through some of the slides I want to touch on. I want to talk a little bit about why bridges are important, some of the current bridge landscapes and constructions, and then I want to touch on some of the complexities when it comes to bridges and some of the potential solutions for bridges going forward, and then a little bit about what we do in it. I'll try to be, this is a complex subject, obviously, it covers a lot of ground, so I have to find the right blend between providing basic information that might be super familiar to people, and then also try to make it understandable and simple, as well as showing a couple of more high complex issues as they relate to bridges. And so let's start with why bridges are important. I kind of when we think about bridges, ultimately the main rationale is that in DeFi and blockchain, we have lots of different open source protocols and projects with super active communities. And the fragmentation of liquidity is becoming an issue, meaning one of the big complexities is that these chains all have different transaction settlement times, for example. Some take a longer time, some are very fast, that it's very complex to be committed to one protocol only and participate in a 24/7 fast-paced global crypto market really, really quickly without having to physically sell and buy tokens. And so a big issue here is that standalone layer ones have scalability issues. And so, there's here we talk about computational bottlenecks, for example, and that's one way you can move a little quicker. And so, a popular one is using Bitcoin to engage with Ethereum, for example, as simple examples. The reason why people like turning Bitcoin into a ERC20 version is because you can actually use it for, my dog says hi, use it for other purposes and actually, engage with NFTs and things like that. Hey. Sorry. And so the other one is what we call money Lego. So isolated liquidity, I kind of touched on that a little bit. It's a super interesting problem for a lot of reasons. The reason why we have isolated liquidity is also why we have currently great rates of return. So as a crypto institution, I like isolated liquidity because arbitrage traders can make a lot of money, ultimately, right? And so what we currently see in the space when you have these insane yields, in the tens of percent up to, very high numbers of percentages in terms of return, often that's because normal market dynamics are hindered because there are frictions in the market around liquidity, settlement times, et cetera, et cetera. So it's a very, very lucrative world right now for people who know how to efficiently trade and interact across multiple different chains and build arbitrage trading entity products. And that's a result of an immature network infrastructure. And so on one hand, a lot of crypto folks enjoy the high yields. On the other hand, it comes with obviously also a lot of risk, and it's really a symbol of network immaturity. And then interoperability, the sort of innovation and adoption problem is ultimately that we don't want to fragment talent too wide. We want to be able to use consensus and value to trigger different applications across different chains. What we're trying to say here is that it's beneficial for chains to live together rather than continuously compete with each other, also when it comes to development of new features on chain, right? And so if everybody aims for the same outcome, we'll probably have less innovation than if people can easily interconnect, and then there's certain standards people just sort of take as granted, and they're like, okay, we're not going to work on that particular problem. We can bridge into that chain for that. We're going to tackle that problem. And so bridges are really the future. The other, as a BlockDaemon company, if you're not familiar with us, we're an infrastructure provider. We operate nodes, white label, and our own branded nodes for foundation institutions, really anyone who wants to safely connect to blockchain networks. We're sort of a bridge ourselves, right? So we guarantee to institutions, mostly institutions that are mostly crypto native, that their node is always running, that there's always their transactions will all hit the node as quick as possible, and they also, if there's yield earning associated, for example via staking, we guarantee yield and we take away slashing risk. And that's a good example of a different type of bridge, where we handle the fragmentation of tokens via a single command line API that institutions can use, and hit it with all sorts of different transactions, pull data, and earn yield via one simple integration, right? And so that's one way to take a lot of the complexity out of the market, and we do that for institutions, and we provide certain guarantees around it, which allow institutions to participate in these networks. And so, yeah, so just wanted to share that. And so really kind of how bridges work, I just want to briefly touch on it. Ultimately, it's a little bit, the easiest way for me to explain it is probably lock and mint. I give you a really silly example, and I'm by no means an expert, but ultimately a bridge, I'd say the standard bridge configuration is a smart contract in which you can imagine you have two chains, call them Bitcoin, Ethereum, Solana, Polygon, where a certain amount is locked in the source chain, right? So it's like, oh, I want to send 10 token X to this chain, to this other chain. So these tokens need to be locked. And that can happen in different ways. Normally it's a smart contract. And then there's a connection to the other chain, and the equivalent value of the tokens that are locked is minted in the new chain. And then in some instances, locked tokens get burned, or they get put into custodial wallets, like BitGo does with the Wrap Bitcoin, for example. But if you think about, that's sort of kind of what that is, right? It's smart contracts talking to each other, saying, hey, these 10 tokens are now locked. And so and then we're creating a dependable value on the other side. Once that occurs, and the smart contract assigns the value to the owner of the locked tokens can vanish and be destroyed, and then they live on in the destination chain. And so the big part here is the monitoring process relies on consensus between network agents, right? And so the consensus mechanisms need to be obviously adhered to, because otherwise you can't put these transactions into ledgers. And so when you operate nodes and when you think about ledgers, ultimately what consensus does and what validators do is they validate and agree the transactions that make it onto a chain. And so you need to join that queue in order to, for example, get the new tokens minted on the source chain. And so that's why network agents, validators, relayers, etc., companies like us are a big part of this, because we often operate the nodes on either side of the smart contract that actually enable the physical bridging. And so, simple. There's a lot of stuff going on. We've got the sources of all the stuff I'm saying, and we can share this if you guys are interested. And so you can see a lot of different chains here. We try to kind of break it out a little bit around the different large scale ecosystems, for example, Ethereum, Cosmos, Polkadot, and then we have different bits. Some of them people like talking about EVM focused chains, so Tendermint focused. There's different bridges in between. For example, the Terra shuttle is a really good one. Terra does great bridging work, for example, between ETH and Terra as a Tendermint version. And then you have all the other different, obviously big chains that you've heard about, Avalanche, the Near Rainbow Bridge, etc., Wormhole for Solana, all these different bits percolating around. You'll see bridges everywhere you turn. The problem is, how do we really evaluate the quality of these bridges, and how can large-scale institutions engage seriously with these type of entities. And so types of bridges. So briefly, just touching on it, there's ASIC-specific bridges, the ones I've described a little bit. Source assets are collateralized. So Wrapped Bitcoin is a good example. They have certain strength, they have a ton of liquidity, but they also have trade-offs, which it's in itself as a bridge not very scalable. You need a new implementation per chain. But it obviously works. It gets a ton of traction, specifically Wrapped Bitcoin. Chain specific, and so collateralizing and minting of assets across specific chain pairs. So Polygon POS bridge is ETH and Polygon, and that's not complex. It can be done really fast, but it's often not very scalable for a lot of different reasons. You have app-specific bridges, and so that can be only for a particular application. So they can bridge across different assets, but they only work in one application. Compound is a good example here. Cross-chain lending, which is super powerful, and that's actually a fantastic product. And you can do a lot of the things that we normally would like to do via bridges, but have to do it via an entity like Compound. And it's obviously very difficult to replicate that across other Compound-like chains. So each implementation is individual here. And then you have generalized bridges. And so, Chainlink is an example of that. That's fun, but often creates security and decentralization risks as well. And so I describe bridges are probably at the state nodes were in 2017. You remember how much time we spent debating decentralization as a community and how many nodes and who controls them. And now you interlay that with bridges, and you come to realize how complicated this all is, and how difficult it is to seriously evaluate the performance of these bridges. Also because these open source communities that drive a lot of the value in these bridges are very, very certain and vested, because they hold a lot of token and making sure that their solution is represented really, really well. And that often can lead to misinterpretations or descriptions of the actual degree of performance of a bridge. And so it's a really complex subject, and people argue a lot about it. And so we have a couple of light client relay node stuff.
I think your video cut out. Would you mind refreshing your browser?
Sure. I'll do it now. Can you guys see me?
Yes. Can you share your slides again?
Yeah, and you can see my dog.
Yes.
Okay, good. That's all I wanted to know. All right. All right. So, yeah, kind of, I don't want to linger too much here. So external validator and federations is interesting. Solana Wormhole. Solana obviously is a protocol that gets a lot of attention these days. That's a really interesting project, and we looked at it for a while. We find that there are still institutional security concerns and also capital issues to run Solana Wormhole as an institutional solution, for example. But it's an interesting one, specifically because we also run a ton of validators. I really like light clients and relay nodes. Cosmos IBC is a great protocol and chain. And I really think that's actually, interestingly enough, maybe the most scalable version over time. Right now, speed and high gas fees are an issue, but it's actually a really interesting way to design bridges. And then we have, liquidity networks. They're very similar to P2P networks. Connext is one, for example, and that's super interesting. Trade-off is often that it's stateful. Really what stateful means is that it relies on other things in order to function, and thus creates security risks. And so there's different types and versions in how you can structure these bridges. They all, like with nodes and decentralization, you can be super decentralized, but then you're not very performant, or you can be high performant and then you're centralized. And it's a progression, and it's a complex one, because most of the underlying decisions evolving these chains have to be done in an open source fashion. And so the old school Silicon Valley, let's build A/B test, iterate until things have a sort of economies of scale of software, or economies of software, is a lot harder to achieve in open source networks. And open source networks, I think, over time are more powerful. They just need a lot longer. And so that's one of the reasons why traditional VCs struggle with a lot of the open source development in nature that we see. So the thing I also want to mention is that bridges have a lot of issues, right? And we have a lot of issues anyway around security. And so there's a lot more vectors for hags. The transferred assets are locked up, often in centralized entities or in smart contracts. As I've mentioned, smart contract locks these tokens so they can live on another chain. When you have a smart contract, you have a piece of software, and that piece of software can have different bits. They can have bugs. There's a bunch of different ways you can play with a smart contract, but it introduces risks. And so bridges introduce additional trust assumptions. And that's complicated when the general protocols already present a huge challenge of trust to network participants, right? And so how can, for example, more institutional type of players trust these bridges at scale? Right now, it's nearly an impossibility. And so we wanted to highlight a couple of things. So in September, P Network, 277 Bitcoin stolen from a BSC bridge. There was a code base hack, for example. Thorchain, which is a great project, actually, and me highlighting some of this doesn't mean that these projects aren't quality. It just means that it's an inherent part of the evolution that they will have issues, and bits and pieces of the bridge will fall off. And so there was a bug within the ETH Bifrost code, for example. So Thorchain has a stateful way of operating. They need other bits to function, and when they don't, they are at risk of losing bits and pieces. And so maybe here I should also point out that if you operate infrastructure in crypto long enough and do it at a large scale enough, you will have issues. Statistically, it's impossible to operate decentralized networks at scale perfectly over time. And so, and interestingly enough, I can even make a computer science argument that proper decentralized chains need to have issues because otherwise they're probably not properly decentralized. And so it's an interesting one. But what I'm saying is, just because Thorchain had an issue doesn't mean Thorchain is any less good. It has technical complexities that are inherent to it, but it's part of the normal evolution of projects in the space, and it's very important to understand that it's part of all of our journey operating this infrastructure in an efficient manner, while we adhere to certain degrees of open source and decentralization, exposes us to risks, and at one point that risk will hit. And then the question is how you're protected from that downside, and I'll touch on that in a minute. But security versus speed, I touched on that previously. The same on nodes. And so, the settlement times, for example, like if you want to do it securely, can be huge. I mean, they're much, much longer than they are on traditional chains. So the Near Ethereum Rainbow Bridge, for example, sometimes has settlement times of over 16 hours. Obviously, that's not a usable application for a financial institution. Imagine you want to do arbitrage trading. 16 hours is a bit of a heavy window here. So what are some of the future things that we foresee that will happen that makes this easier? A lower header verification cost, and so a lot of people are working on that stuff, and so that's that works for something like IBC, for example. And so we talked about costs being an issue there, so that'll be a really important evolution for that project, and take away one of the hindrances currently to turn it into something super, super powerful. The greater adoption of bonded and insured models, that's sort of where we come in. Bonding and staking model provide additional economic security for bridges. And so, you can build different types of products. So for example, we thought about partnering staking yield with lending yield, and then guaranteeing flow across bridges. And and earn a percentage for it. And so it's a complex product. And I'm not going to describe it too much at this point because it's still something we're thinking about. But there's ways you can build in certain guarantees and you can make it economically viable to give those guarantees. And the other ones is insurances, which companies like us are actually fairly comfortable with around staking and slashing, where we already have insurance and we provide insurance to our partners. We cover the slashing risk 100%. And so, and you could do the same with bridging, and that's one of the areas we're thinking about. Can we guarantee transaction settlement time on bridges, and can we have enough liquidity pools in native tokens that we can jump in and ultimately make the bridge a financial product, and technically a lot easier. And so, but that introduces the component of a centralized entity pushing a lot of assets on a chain, but it's something we're looking into. Bridge aggregation, lots of projects are doing that. And so there's some great projects on the way. I don't want to name anyone specifically because there's actually a lot of them. This is a huge area, sees a lot of investment, super difficult to do technically, but a huge area of opportunity. So sites and folks where people that just sort of build, run 20 bridges across networks and do that for a living, right? And so there's some sites that do just that, and you can hit me up and I can point you to them. I want to touch on BlockDaemon just quickly. And so we're obviously a node infrastructure player. Really what makes us specific is we monitor and run a ton of nodes, and we do that pretty well. We also insure all our nodes. We have failover systems across different territories, data centers, et cetera. We can handle a lot of different instances in order to guarantee the uptime of a chain. And so there is always you guys run a lot of infrastructure on the network. For us, there's a certain dedicated limit like that we don't want to overstep. So we don't want to run every node, but we want to run the heavy institutional nodes that need insurance, that can be an important part of underpinning a network's performance. We work with a bunch of folks. I don't want to bore you with this stuff. And then there's a bunch of different source material that we've used in order to create the presentation. We can share this deck with the wider group if interested, and you guys can read some of this yourself. But ultimately, this is going to be super exciting, and abstracting away this complexity is going to be key. And so, we do that with APIs for particular nodes already. Doing it cross-chain is really the next step, and it'll be so interesting to see how the industry evolves in doing it. And so that's sort of my bit here. I'm going to stop sharing. And so, so Leo's sleeping in the back. We have 7 minutes left. I don't know if you guys have any particular questions. Otherwise, you guys have a coffee. But so very generic, difficult to lay it all out in a short period of time, but hope it made some sense.
Yeah, definitely. So I think people might need some time to come up with questions. What are some very common questions that you get around bridges, like when you deal with institutions or deal with DeFi projects or like infrastructure?
Yeah, I mean, the most common thing often is really ultimately that there's no predictability. And so the question we always get is, what is the performance and predictability of these different bridges, so they can evaluate and build architecture that can connect to them? And I'd say often that's the first stumbling point, right? And so very difficult to find a bridge that has stable patterns of performance that you can also, as a provider, guarantee. And so I think for institutions, obviously, I'd say the non-crypto native institutions are very far away from this subject. They're currently dealing with let's figure out how we allow our customers to hold Bitcoin in a wallet, and then they might think about staking probably when ETH 2.0 comes live, because that's going to be a product that they will need if they want to allow people to hold Ethereum. And that will be the largest sort of DeFi evolution I think we've ever seen next year. And then after that, you'll have settlement across chain, only if it can be as safe and fast as direct settlement of liquidity. And so it's a huge complex issue for institutions, right? And so I don't know if bridges for institutions will work that way. Institutions, developers obviously like bridges for cross applications. I think bridges are very, very powerful. Other than that, I think on large volume, we still have a long way to go. And then I like the question. I mean, DAOs are great. I mean, ideally, everything would be a DAO. So that'd be really cool. Like, and so, like I think that's the way these bridges need to be run. And so to me, that's probably the ideal state. It's just that DAOs are hard, right? Like you need a really evolved community. You need to design the structure really well. It's difficult to come back from a poor architected DAO. And so, but that's obviously a really, really good way to make it work and to make it systemic, right? Which is kind of what we like. Ideally, we have software driving the tactical transactions and a rich community of developers doing the strategic evolution of the tactical direction. And so I think DAOs are a really good way to do that. Yeah, I mean, lots. Legal considerations for bridges. I mean, I wish I had an answer that's satisfactory. Obviously, we know the regulatory frameworks are difficult and not clear. We experience that every day, and I think there are legal considerations for sure, depending on how you and who you operate it for, and so the devil is really in the detail. Ultimately, there's a definition of what a money transmitter is in the US, and you can look it up. There's a couple of points that will define, if you adhere to one of them, that you're a money transmitter, which requires a particular license to be held in the US, for example. One of them is if you enable transactional yield earning on any type of security. And so even technically enable, right, which means you don't control it, you don't have custody, you don't know anything. And so actually, interestingly enough, a smart contract could need regulation if that were true, right? So how do you apply that type of regulation to software? It's difficult. It's totally novel. And how do you provide it to something that isn't owned by an institution or an individual, but it's actually a piece of code? And so there's a lot to be thought about here, and it's a super lengthy conversation on how that's done. And we're all going to be in the margins of regulation for a while, and for us as BlockDaemon as well, that was one of the reasons why we raised a ton of money recently, is because we're an organized entity that's large enough to get attention from regulators. So we need to adequately deal with it in a proactive manner, right? Which is, we want to be on the right side of the law. We want to and we want to facilitate technical evolution, and we want to do it at a global scale. So we need to interface with different legal communities around different subjects around the world, and that's unfortunately requires a lot of resources. And so we'll try as an institution to tackle a lot of this also for the blockchain space, specifically when it comes to settling and transactions on chain. And so, but yeah, it's going to be a super lengthy, interesting process. And so it's not, bridges per se aren't super, I mean, trust me, regulators and government agencies don't understand this one bit at this point, because we don't really fully understand it either. And so, I think we'll have a little more time before it explicitly gets pushed into regulation, but it'll come.
Awesome. Konstantin, this was great. Do you mind sharing your slides either in the chat or on Twitter?
Sure. I'll put it on Twitter.
Okay, perfect. Awesome. We're going to transition to the next session now. Thanks again.
Bye, guys.